Hey everyone, welcome back. Today I'm going to walk you through the project that I built called as WeatherIQ. It is a fully functional advanced weather application built entirely in the Python. This is not just a basic script that prints temperature to a terminal. This is a complete desktop GUI application with live API data, automatic location detection, hourly and the daily forecast, unit switching, animated loading, and the proper error handling all wrapped in a clean dark theme interface. Let me show you how it look like first. Then we will dive into the code. So now I will run the application. If I run the application, then it will open. Okay. So here is the app is running. So you can see the dark interface with the title Weather IQ at the top. Let me search for a city. Like if I search for a city like London, then I will click on the search. So it will fetch within a few seconds or two. It will you can see it fetch the live weather data. We get the temperature and just a second. We get the temperature, the weather condition. It feels like humidity, wind speeds, and also the hourly forecast weather wind speed, what is visibility, and even sunrise and sunset time also. Below that we have the hourly expected forecast. So we can show the below there the hourly forecast data set that is next 24 hours. You can scroll it down horizontally to see all the time slots, and each slot has an actual weather. We can say like it has actual weather icon downloaded live from the API, and at the bottom it will show the 5-day forecast. Each day shows the high, the low, and dominant weather condition for the day. Now I'll click my if I click on the my location, it will show me the my location as well, like where I'm still, and it also fetches the click my location, and then it will be automatically detect where I am using the IP geolocation, no GPS hardware needed, and fetches the weather for my country for my current city. And one more thing that I can switch between the Celsius and the Fahrenheit. If I want temperature in Fahrenheit, it will simply call it, and it will just simply convert it. It will just simply convert the Celsius into Fahrenheit with the basic formula that we can use, and see how everything update instantly, refetches, and convert all the values. Now I will show you the project structure that. So now let's talk about the how the project is organized. So here it is basically. So I actually have followed the proper modular architecture, not everything dumped in one file, and it will point to each file that I have built. So it has a GUI, service, and utils, and the config.py files, and the folder handles everything visually, and the app windows and reusable widgets, and the services will be called as it will handles all the external communication, the weather API and the location detection. The utils folder will be used for the as a pure conversion function like a temperature and speed. And here is the config.py file. It is a single source of the true colors, the truth of the colors, fonts, and the API key, and also at the .env file where the API key lives clearly. Here it is, but I can't open it. It's just publicly released. So So this is a kind of a structure means if I want to swap the weather API tomorrow, I only touch one file. The GUI doesn't care where the data comes from. Now I will show you the code. So this is the config.py file. This is where I load the API key using the python.env file, and no, just a second. Load.env file. The key never appears in the actual Python code. It reads from the .env file at the runtime, and I also define all my colors and the fonts here. So we can say that the colors, background, header, card, and card font, error, success, and fonts that Helvetica is a font that I've used. Weather emojis also generated from the AI. And now I can show you the services logo. Yes. So in this, it will serve all the weather services. What it actually does, I can simply. So this is the brain of the data layer. This is a get current weather method that it will the API request, and it works either the city name or the coordinates. So both searches and auto location use the same function. And I can show you the check response function. Here is the check response function. Here I will handle all the every possible failure by 401 for the invalid key, 404 for the city not found, and 429 for the rate limiting. Each one gives the user a clear message instead of a raw crash. Instead of a raw crash, then I can show the pass forecast function method basically. Here is the it will show you either takes the raw 3 hourly API data and split it into the two clean list, one for the hourly display and one aggregately into the daily summary. And this is a pure Python logic that I have used. No external library will be needed. And then now I will show you the GUI file. Here it is. So in which the GUI file has in the app.py file. So the first one is the start fetch method that will. So here is the start fetch method, and that is it is a most important thing in the GUI, that is a threading, highlighting threading part. So what we are doing, every single API calls run inside the background thread. This is why the app window never freezes while the data is downloading. So thread finishes, then calls self dot after. So here I have used the self dot after function. What it will do, it will safely update the UI back on the main thread. That's the correct Tkinter pattern. That is it. Now I will go to the sync load icon. Either here what it will do, it will generate the icons or download it in their own threads. And if the download fails for any reasons, then the app gracefully falls back to the Unicode weather emoji, so user never sees any broken image. Now I can show you the component file. Here I actually made all the function that I previously used. So here the component file will be the separated all the reusable widgets in their own classes. And the detail card is also the one of the example that it is a mini card that shows any weather metric. Hourly card and the daily loading schemas, they all are here. This is basically object-oriented programming. Uh, each widget knows how to build and update itself, and the main app just creates them and passes them data in. So now I can switch back to the. So now the this is all that I have made. To summarize, the Python plus Tkinter for the GUI, OpenWeatherMap API for the live weather data, and the Python.env for secure the API key management, and Pillow for the real weather icon images, and the threading to keep the UI responsive, and fully modular architecture that's easy to extend. The whole project took carefully planning and separating the concept between the GUI layer, the services layer, and the utility layer. Make sure so errors are handled gracefully at every step, so and ensuring the code is readable and the business friendly. So I can you can simply just run it your two steps. Just add your free open weather map API key to the .env file and just simply uh, python.main. Just simply run python main.py. So that's the weather IQ. Thanks for watching. And if you have any questions, drop them in the comments below. Thank you.